The next topic is hardness. Hardness is the property that describes how strongly a metal resists indentation, scratching, and wear. So, in practice, it tells you how durable the surface will be under contact, friction, and repeated loading. We commonly measure it in three typical ways. First one is Brinell hardness, Rockwell hardness, and Vickers hardness. First, we see the Brinell hardness. Brinell hardness, press a large hard ball into the surface. This is our surface. This is a large hardened ball. We press a large hardened ball and we measure the dent meter. The circle in the block is the indentation with diameter D. This is the diameter D. This is indentation. So we measure the dent diameter, and Brinell hardness is good for casting and forging. Next one is Rockwell hardness. Rockwell hardness measure indentation depth. Here we measure the depth. Here depth load. We put a major load here. This is diamond cone 120 degree and major load here we put. Then we measure a indentation depth under setter load. This is used for fast and direct reading. Example HRC and HRB. The next one is Vickers hardness. Here we use a diamond pyramid. This is a diamond pyramid and measure the square intense diagonals. Here we measure the diagonals D1 and D2. Precise and works for, here we using a microscope. Works for thin layers too. Why we are using this? Because the harder metals wear less and keep their shape under contact. Example, hardened tool steel has high hardness. This having high hardness, so its edge stays sharp and can cut softer metals. This is the example. So next topic is toughness. The ability of a metal to absorb energy and plastically deform before it fractures. Think strong plus ductile is equal to toughness. So it bends and stretches instead of snapping. And the tough materials give warning, that means yielding under shock or impact, and help prevent sudden and brittle failure. How we check this? Impact test and stress strain curve area. So impact test shows how much energy a notched sample absorbs. How much energy. And stress strain curve area, this is for fracture. It indicates total energy absorbed. It indicates the total energy absorbed. The example is structural steel in earthquake zones needs toughness to avoid sudden breakage. In earthquake zone structures and welded frames, steel must have enough toughness so they avoid sudden breakage under rapid or cyclic loading. This is the toughness. The next topic is ductility. Ductility is the metal's ability to stretch under tension and be drawn into thin wire without breaking. It means the material prefers to deform rather than crack when pulled. Under tensile loads, here we using tensile loads. Under tensile loads, a ductile metal gives warning, it elongates and necks. So, sudden fracture is less. That's safer in service and useful in manufacturing. Manufacturing, it means wire drawing, bending, forming. This is all the manufacturing units, and best example is copper and aluminium also best example. Copper wiring is very ductile, so it can be drawn into long and thin wires.